already seen these definitions in our first notes, but I wanted to formalize them. Because a lot of what we're going to be doing today, guys, comes down especially to these two pieces. Are we finding a part-to-part or a part-to-whole ratio? And you need to understand, we're going to do both. You need to understand when you're looking at your ratio what type it is, because the whole key for today is finding my ratio constant. Remember that in a part-to-part ratio, what I'm looking at is a ratio that compares two pieces of information. So I'm looking at parts of pieces. In a part-to-whole ratio, I'm looking at comparing a ratio that compares a part to the total number possible. Okay? In the problems, they're not going to tell you what kind of ratio you have. You need to be able to look at the problem, break it down to our marking the text strategy, and understand what type it is. Most of what we're doing today is a whole bunch of word problems where we're actually solving for missing information. So to do this, when we're doing ratio comparisons, I've developed this 5-step process. The first thing you need to do is draw your tick diagram based on the information that they've given you. Make really certain that you pay attention to the language. Stuff like more than. Okay? These are some key words that you're going to see. Total, less than. These are going to be really important words as you're trying to take the information and break it down into what you're actually needing to find your ratio constant. Because it's telling you what you're comparing. For all these problems, they must give you a third piece of information. Can you move a different chair? Stop. Okay? If they don't give you a third piece of information, you literally couldn't solve the problem. You can't solve the kind of problems we're going to have today with just a ratio. They're going to give you another piece. The whole key is taking that piece and using that to determine your ratio constant. Yes, Paul?
Are you going to give us a piece of homework like that just to kind of mess with us?
Yeah.
Just to see if
We're giving you 2 pages of that homework, actually. And it's not just to mess with you, it's to develop your skills. It's how you think about it. Third, especially in the second lesson, page 23 today, they're going to give you a before and an after scenario. You need to draw tape diagrams for each of them. One tape diagram is not going to cut it for you. The nice thing about them, when you're looking at them, you should be able to figure out your ratio constants for one from the other. Okay? So pay attention to the information it's given you. Sometimes the ratio constant will directly transfer over if things haven't changed that much. Sometimes you'll need to redo it, but you'll be given the information to be able to do so. Step 4, place the ratio constant in your diagram. Once you've got the ratio constant, stick it right in there, guys. It's going to make it all make more sense to you. And then finally, you're going to solve. Make sure you're answering in full sentences. Can't hit that enough. Questions on the notes? Okay, again, remember, if you don't get it in class, you can always look at this later on YouTube. Let's go ahead and open up to page 16. Okay, on our first problem here, we're really going to kind of take this slow, guys, because the module is trying to make it so you can work through this and see step by step how am I solving these things.
You said
Page 16. It's also right here on what's right there on the board. Oh, I scrolled down. So on our first one, let me just say it again, guys. Marking your text is going to be your lifeline in this stuff. Look at all this information in here. If I'm not marking the text to pull out this information and make it make sense, I'm going to be lost on the problem. It's not hard, so let's just walk through it. So County Superintendent of Highways is interested in the numbers of different types of vehicles that regularly travel within his county. In the month of August, a total of 192 registrations were purchased for passenger cars and pickup trucks at the local Department of Motor Vehicles. The DMV reported that in the month of August, for every 5 cars, there were 7 pickup trucks registered. how many of each type of vehicle were registered in the county in the month of August. So there's my question. That is what we're eventually going to need to answer. So before we do that, let's look at the steps that we can take in order to get there. So first off, using the information of the problem, write 4 different ratios and describe the meaning of each. So we have 2 parts here. We need to write 4 ratios and describe their meaning. So given what we just talked about in the notes about part-to-part, part-to-whole ratios, looking at the numbers that they have given us, who thinks that they can give me a ratio for this problem? What do you got? Okay, 5. What would the 2 come from?
Okay, 5 to 7.
Okay, 5 to 7. What are those? What's the 5? Cars. What's the 7? Awesome. So 5 to 7, that's comparing cars to trucks. Did I do what we just said? Did I write one ratio and describe the meaning? Yeah. So what's another ratio I can use? Go ahead.
192 registration, total registration, and the month of August for 5 passenger cars registered.
Okay, the problem with that is you're comparing 2 completely different things. So I could have used the 192 to something else, but let's hold off on the 192. I'll give you guys a hint. We're not going to use the 192 yet. Let's keep focusing on the 5 and the 7. What's something else I could say on that? But I like where you were going with total. Someone else come up with one? Mikey? Not? Go ahead.
9/12, month of August.
Why? Where did 9 come from?
8, and 12.
What's 8 and the 12?
The 8 is the month of August, and 12 is the cars and the trucks.
Okay. So I like your 12. I don't like your 8. Because is the month of August being compared to the cars and trucks? No, it's in the month of August that we're looking at this comparison. So think about what you just said. Is there something else I can compare to the 12 then? Part to whole. I can do 5 to 12, which would be comparing what?
The DMV reported that
5 is what?
the car.
Cars. 12 is what?
The truck. The cars and the trucks. I know.
So let's use the word vehicles for that. Since they use the word vehicles, so we can say cars to vehicles, right?
That would be a part to whole, right?
That would be a part to whole ratio. Okay, so that's 2 ratios. We need 2 more. Who will give me 2 more? Go ahead.
7 to 12.
7 to 12. Awesome. I love it. What is that?
That's the trucks.
Trucks to
Trucks to vehicles.
vehicles, right? I need a 4th one. Levels? You just want to take that one? Okay. Yes. 7 to 5 would be trucks to cars. Awesome. I can just turn the ratio around, right? If I turn the ratio around, is it different?
Yes.
Yes, it's got a different value. 5/7 is different than 7/5. Okay, so there's 4. That's all we needed, so that's all we're going to do for now. But yeah, I can think very easily of at least 2 more, but there's several other ways to look at these. So now we're going to make a tape diagram to represent the quantities in the part-to-part ratios that you wrote. So I'm only going to make one, so I can pick either one. You guys want to do the 5 to 7 or the 7 to 5? Because those were our part-to-parts. 5 to 7? Okay. So if I'm doing 5 to 7, how many boxes go on top? 5. Why? Because that's the first number in our ratio. What goes on the bottom? 7. Why? Because that's the second number in our ratio. And then, because I'm drawing a tape diagram, I make sure I always label them, right?
Yes.
So what was it we put on top?
C.
Cars, C. What did I go? What's on the bottom?
Trucks.
Trucks, T. You guys starting to see how these all come together?
Yes.
Pretty easy, right? Once you start thinking about it. Now, how many equal-sized parts does the tape diagram consist of? Ooh, there's kind of a trick question we haven't thought of yet. Mikey, you think you got it? You can't count? Which part don't you understand? Mikey, do you see that in the problem? If I scroll up here, it says 5 cars to 7 trucks. Do you understand that? So to write that mathematically, to translate from English to math, all I need to do is say 5 to 7 using a ratio. Does that make sense? Now if I want to transfer that to a tape diagram, I'm just going to keep that order. So whichever ratio I chose, that's what I'm going to do. This is the one we chose to do, because you guys said you wanted 5 on top. So if I'm doing 5 on top, how many boxes go on top? 5. What was that?
Cars.
So I label it cars. What goes on the bottom? Well, what's my next number?
7.
How many boxes does it get?
7.
What letter do I label? Why?
T.
Because T is what was second. What part of that doesn't make sense to you? None of it? So you don't understand 5.
Oh, I get it now.
You just said none of it made sense.
He meant none of it doesn't make sense.
None of it, oh. Double negative. Gotcha.
Right.
Okay? There's a reason in English they teach you not to use a double negative. It gets very confusing. So now you're good. Okay, let's get back to our question. How many equal-sized parts does the tape diagram represent, really?
1.
No.
2.
1 is right here. That's one equal part, right? How many equal parts are there in my tape diagram? What do you think, Leah? 12. How'd you get that? Counted, right? Counted 5 and 7. You put it together, that is 12. Because it's a word problem, we'll answer in a full sentence. There are 12 equal size boxes. Okay? So does everybody see that we have 12 boxes in our tape diagram?
Yes, possibly. Yes.
Good. So what total quantity does the tape diagram represent? We kind of used that when we talked about the part to whole ratios and had to figure out what the label was for the holes, right? What did we call it? Ezekiel? Is it Ezekiel? What's your name? Zachary, sorry. What did we call it when we put them all together? Vehicles, right? So what total quantity? The quantity is the total vehicles. And I apologize, every once in a while my smartboard freezes out, but you can hear what I'm saying, even if you can't read it all. So the quantity is the total vehicles. Does that make sense?
Yes.
Quantity is the total vehicle.
Yep. Okay, go ahead and turn the page.
Hang on, I'm still writing now.
It's still there. That's why I put them together, because these all kind of go together. So what value does each individual part of the tape diagram represent? So we said there's 12 equal size. We said the total quantity is the total vehicles. So what could I say about each individual box in my tape diagram? What does it represent? Well, what did we call that? So what is one box equal?
One vehicle.
One vehicle, right? So each box is one vehicle. Okay? Because we're looking at it from a whole perspective or a total perspective, each box is one vehicle. We know that the row, those on the top row are cars, those on the bottom row are trucks, but altogether each one is a vehicle, right?
Yes.
Everybody tracking so far?
Yep.
So now we're to the major question we had. How many of each type of vehicle were registered in August? There's what we started with as our first one. So guys, I apologize. Go ahead and flip back to our first page. But now is where we're going to need to get to the one you were trying to use with the 192. Because remember when I said in your notes, they always have to give you a third piece of information?
Yeah.
Here's where this comes in. That third piece of information is where I find my ratio constant. What I have to do, though, is link that third piece of information to what I see in my tape diagram and understand how they're related so that I understand what I'm dividing by. Does that make sense so far?
Yeah.
Yeah.
So let's look at that third piece of information. What did they give us? A total of 192 registrations were purchased. So what am I comparing that 192 to? Am I comparing it to the 5, the 7, the 12?
The 5,
Waffle?
the 5 and 7. Because that's the trucks and cars, right?
Right.
Yeah.
So am I comparing it to the 5 or the 7?
Both.
Which would be what?
Well, oh yeah, the 12. Yeah.
So I'm comparing it to the 12. So to find my ratio constant, what am I going to do?
Divide by 12.
Divide by 12. Make sense? So I take the number they gave me, 192. I'm going to divide it by 12. So that gets me a 1, gets me 6. So that gives me a ratio constant of 16. That's my ratio constant. So now that I found my ratio constant, what do I do with it?
How
Hey,
did you do
John.
that math that fast? 12, 192.
Put it in every box, right?
Yeah.
Now that I found my ratio constant, I can put it inside every box. Now that I have it in every box, I can actually apply it to figure out how many of each vehicle were registered, right? So how many cars were there? How many boxes?
5.
5 boxes of 16 gives me what? 80. 7 boxes of 16 gets me?
96.
No. That would have been...
Wait, no. Oh, 92.
No.
I was
Avery? 112.
I don't know.
Yeah, you just added one more 8 to 80. You didn't add 2 more. Okay? So, to answer, now we can flip back over because we've got the numbers. How many of each type? There were 80 cars and 112 trucks registered. You could add in the month of August if you want, but everybody good?
Yes.
Gonna up our game a little bit. Yeah. Okay, y'all got it. Okay, let's look at the next one. Guys, is this right?
You just go.
Oh, looks like
I'll go back. I think this one is put together.
right here. Okay. Okay. Here we go. Does somebody want to read it?
Me.
Okay. What?
The superintendent of highways is further interested in the numbers of commercial vehicles that frequently use the county's highways. He obtains information from the Department of Motor Vehicles from the month of September and finds that for every 14 non-commercial vehicles, there were 5 commercial vehicles. If there were 108 more non-commercial vehicles than commercial vehicles, how many of each type of vehicle frequently use the county's highways during the month of September?
Okay. So, actually, I've boxed this whole thing. This is our question.
Yeah.
A lot of information in here, guys. A lot of information. So what is my question? What am I trying to find? Zachary, talk to me. You've been on a roll, buddy.
You're trying to find how many of each type of vehicle actually use the country highway.
Very good. Okay. How many of each type of vehicle? I'll put it up. All right. We've got one more, and then it's all you. Okay. So what am I going to start with? What ratio am I given? What do we know? What do we know? Yes.
14 to 5.
Okay. Oh yeah. I can't really see it. 14 to 5. Okay, here we go. Uh-oh. $14 to 5.
Should we write down the ratio first and then do that?
Yeah, we can. Absolutely. Thank you. Okay, then we're going to do 5. All right, now do we need to do anything with this tape diagram?
Yes.
Label it. Thank you. I heard it. Good. Okay, so what's my top? What's the top?
Non-commercial. Non-commercial.
Non-commercial, and then the bottom is?
Commercial.
Commercial. Okay. All right, we've got that. That's what are they asking us to do? Zachary said if there were 108 more non-commercial vehicles than commercial vehicles. That's a little different. That's a little different. What do we need to do here?
We need to divide, don't we? Because if are we trying to get a ratio constant right now?
Are we?
Because when we need to add 14 and 5 and then divide that by 108.
Hold that thought. Snow.
So we would divide 108 by 14 to get a ratio constant. So you can find out how many commercial vehicles there are.
Okay, but right here, Chanel, it said, this is a key word right here, 108 more. Oh, more. Okay, if we use all 14 boxes, is that how many more?
No.
No, how many boxes more did the non-commercial vehicles have? How many? That's all you're getting. 9. 9. Okay, so right here, this is 9.
Wait, why would it be 9 more boxes?
Okay, because, talk to us, yeah.
Actually, I just wanted to point out what Avery did and why this tape diagram is so nice, guys. I watched him, and what he did was, as soon as he raised his hand, he actually started counting. He literally was able to just physically count. And he said, well, look, they both have 5. So he started at that next one and just counted. And he said, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're able to count and actually see it. That's what again, one of the advantages of this tape diagram. It physically lays it out for you, right? It made it really easy to count because there were 9 more on the top row.
He's explaining it right here. What Mr. Morse just said, what Avery just did. These are the same, right? 1 to 1, 1 to 1 to 1. How many more boxes does non-commercial vehicles have than commercial?
Oh.
Right here, this big gap right here. And like Mr. Moore said, he literally just counted the boxes that were extra on top. Or how many more there were. Okay? Are we good there?
Yeah.
Okay. Now what are we going to do?
Divide by.
Now. Yes.
108 divided 14, right?
No, divided by 9.
Courtney. Or Bubbles.
No, divided by 9.
Talk to us.
So you divide it by 9.
Okay. Let's do it this way. Which would give us what?
12.
Okay. So what is my ratio constant?
12.
12. Each one. Right? Okay. Okay. Good. Okay. Now is that it? Are we finished?
No.
No, that Zachary said.
We have to add up all the 12.
Right. How many? Wait. Of each type, right here. Of each type of vehicle was used during the month of September. So
have to add up all the goals.
Okay,
And
good.
then that'll be right.
So, what's the top row?
14, I don't know.
14 times 12.
Just gotta wait for my first answer and I'll
See? And that's what I know y'all do.
accomplish.
What is it?
I am
168.
168. Good. And then the bottom row? 60. Okay? Am I finished?
No, yeah.
No, why is that?
160.
Okay, we did that. Why though? What do we have to do? What does Mr. Moore always say? It's a word problem, so we have to write it out. We have to write it out in a complete sentence. So let's start here. There are 168 let's see. Yes, where are we? Non-commercial. And 60
commercial vehicles.
get down at the bottom, it gets a little, but
Why doesn't that make sense? Oh, it's just because of the board.
yeah, it messes up at the bottom. This is an M.
It's supposed to be at least.
It's supposed to be, exactly.
That. I'm talking about the multiplication. Yeah, well, no, because
2 times 4 is 8, 2 times 1 is 2. You always put that placeholder. 1 times 4 is 4. This is a 0, I don't know. There. So we put an X. Okay. Are we clear?
yes, that's right.
Okay. I'll give you a minute. Any questions?
No, ma'am.
Okay. So you're doing okay with those boxes that were more than. All right. Okay. Zachary, what's that? You're good? Yeah, we're going to get to that. Okay. All right. So guys, the next page, right, we're going to give you, right here, a few minutes to do this on your own. Okay, you can work with your table. About how many? 8 minutes? Or do we have?
Let's give them 5
5 on this. Okay.
So, guys, I'll tell you what. Pick 2 of the problems as a table. Solve 2 of the problems. We're giving you 5 minutes. Page 18. Page 18.
All right, let's look at these. I'll wait over here. Okay, and then we'll go over the other 2 if any of you need those 2. But I think most people are working on the first 2. Let's look at what we have here. The ratio of the number of people who own a smartphone to the number of people who own a flip phone is 4-3. If 500 more people, 500, can't see it. More people own a smartphone than a flip phone. How many people own each type of phone? Okay, again, guys, you see that more. How many boxes more was a smartphone than the flip phone? 1. Okay, and I saw there were a couple of students in the earlier class, they're like, but if I just divide it by 1, it's 500. Exactly, and that's okay. It was 500. 500 is your ratio constant, okay? So you put it in each box. There were 2,000 people that owned the smartphone. After you added those up, 1,500 or 1,500 that owned the flip phone. And then I wrote it in word form. Okay? Right here, Sammy and David were selling water bottles to raise money for new football uniforms. Sammy sold 5 water bottles. For every 3 water bottles David sold. Set up your tape diagram, 5-3. Okay? Together, they sold 160 water bottles. How many did each boy sell? Why did I use 8 to divide by? Why did I use 8? Talk to us, Zachary. Yes, I divided by 8.
You said a box, so 8 boxes.
Yes, very good. He said 8 boxes altogether. We're doing together, Sammy and David. Those are 8 boxes. So we're going to divide, and here's my ratio constant. 20 is my ratio constant. Okay? That goes in each box. You do the math. Sammy sold 100, and David sold 60. Water box. Any questions?
Is it great if we don't finish both because our group only got to one?
No, this is classwork. So just, it's up to you. Okay. All right. Is everybody okay? All right. Did you want to?
We're almost out of time, so real quick, let's go ahead and flip to the next page. Page 19. Okay, here's your first page of homework, guys. Going to tear this one out? While you tear it out, I'm going to point out a couple things. You need to make sure you're paying attention to what they are giving you. In this case, total of 195 campers, total number of students and faculty. This one is more snowboarders. Okay? Guys, you've got to pay attention to what they're giving you. Okay? Go ahead and flip to page 23 as well. Tear it out. Okay, guys, listen up. Guys, please. Listen up. That means stop talking. Right in front of you, that's not a good idea. On this one, this is where we're doing before and after tape diagrams. So I need to look at these. I'm going to do a before and an after for what I'm doing. Now, guys, I highly recommend, if you're struggling on this, when you get home tonight, look at the YouTube video. Because I'm going to go ahead and pause it here, but I'm going to actually work out a couple of these kinds of problems on the YouTube video so that you'll have something to look at if you're struggling with this when you get home. Okay? So again, look up KMS 6th grade math or Guy Moore. It will show you where the videos are. Yes? Yes. I actually have, our planning period is 8-4, so during next hours when I take the time to upload this and make sure it's on the web for you guys. Okay. Okay, class is out, but I'm going to go ahead and do a couple problems so you guys have at least some examples on these before and the afters. So during the this was actually page 22, so this is actually the back side of your homework. You're not required to do this. We won't be checking it in class. However, it allows you to work along at home if you're struggling on this. So during the first semester, the ratio of the number of students in art class to the number of students in gym class was 2-7. However, the art classes were really small, the gym classes were large, so the principal changed student classes for this second semester. In second semester, the ratio of the number of students in art class to the number of students in gym class was 5-4. If 75 students were in art class second semester, how many were in art class and gym class first semester? So we actually have a double question here that we need to answer. So the important thing on this is if you're given a before and after, you need to set up a tape diagram for both. So in this case, we're going to say first semester and second semester. We started out is a ratio of 2-7 of art to gym. Second semester, that changed to 5-4 for art to gym. So if I do 2-7, I have 2 on top, 7 on the bottom. And that's art to gym. Second semester, that changes. We're now doing 5-4. and that's still art and gym. Now looking at the information they gave me, it says 75 students in art class in the second semester. So I need to figure out the number of boxes in second semester. It means I'm taking the 75, dividing that by 5, and that's going to give me 15. That is my ratio constant. Once I have my ratio constant, now it goes into every box. Now, one thing about this one is the number of boxes for both semesters and the number of students is the same. I have 9 boxes in first semester, 9 boxes in second semester. So that means that my ratio constant for first semester is also 15 for every box. Now that I found that out, now I can actually do the math. So I had 2 boxes of 15 gives me 30 students in the first. 7 boxes of 15 gets me 105. So how many were in art class and gym class in the first semester? My answer would be there were 30 students in art and 105 in gym during first semester. So 2 things, make sure you're marking the text to help you pull all that stuff out. Make sure you're using the information they've given you in the appropriate spot. So let's look at number 7 then. Jeanette wants to save money, but she has not been good in the past. The ratio of the amount of money in Jeanette's savings account to the amount of money in her checking account was 1 to 6. Because Jeanette's trying to get better at saving money, she moved some money out of her checking account into her savings account. Now the ratio of the amount of money in her savings to the amount of money in her checking is 4 to 3. If Jeanette had 936 in her checking before moving money, how much money does Jeanette have in each account after moving money? So there's our question. And again, we're looking at a before and an after. So this I'm just going to label the B and the A. So before the move and after the move. So before the move, her money was in a ratio of 1 to 6 in savings to checking. After she moved it, it switched to 4 to 3 in savings to checking, just to make sure that I've got my ratios in the right manner. So setting up my tape diagram, I have 1 box to 6 boxes. Oops, that's not a 1. That should be S for savings and C for checking. Afterwards, now it's a lot more balanced. We're at 4 to 3. And that again is savings to checking. Again, we always have to find that third piece of information that they've given us. In this case, it's this piece here. She had 936 in checking before moving. So I have to go back, see how many boxes did I have before I moved. So I'm in the before time in checking, and I can see I have 6 boxes. So I'm going to take that 936, divide it by 6, and we've got 1, 5, 6. So that makes my ratio constant 156. So I can now put that 156 into every single box. Once again, I had 7 boxes before, 7 boxes after. I'm dealing with the same amount of money. That means my ratio constant actually carries over. So I can use that exact same ratio constant in my after as I did in my before. So I hit a couple dead spots there on the board. That 5's not coming in on that last one. But realize that's 156 inside that box as well. So now I can do the math. I've got 156 times 4 for my checking gets me 24, 22, 624 in savings, and 156 times 3, 18, 16, 468 in checking. Go ahead and write that into our full sentence because we are looking specifically for how much after moving. We will say Jeanette had $624 in savings and $468 in checking after moving her money. So hopefully that gives you guys a good basis for the homework on page 23. If you have any questions, please stop in and see Miss B or myself at lunch. You can come in and see me after school, or you can always request to come in at seminar on Tuesday or Thursday of next week.